السلام عليكم ورحمة الله وبركاته. أهلا بكم أبنائي وبناتي طلاب الصف الثاني الثانوي. إن شاء الله أولا نبدأ بتحية لكم جميعا أبنائي وبناتي الطلاب، مع تحياتي أنا حسام حسن، منصة البث المباشر بوزارة التربية والتعليم المصرية. نبدأ إن شاء الله في حلقتنا النهاردة اللي هي حلقة الكيمستري. طبعا احنا في السيشنز اللي فاتت عملنا الكلاسيفيكيشنز اوف elements وعملناها عملية classify into 4 sub levels، وقلنا each sub levels express about the type of elements. The type of elements classify into 4 types: S block, B block, D block, and F block. S block classify into 1s2, it is inert gas or noble gas, and NS1 into 2 electrons, so it is a representative element, S block. We have B block, B6, NB6, it is expressed about inert gases or noble gases, and B from 1 to 5 is representative elements. D block in the middle express main transition elements, and below the F block inner transition elements, not main transition elements. Representative elements, the locations and the orbital rotation locations of these types. We can collect these types and put it in modern periodic table. We have a history about periodic tables. Periodic tables in the last consists of very little atoms. These little atoms may be 9 elements only. These 9 elements doesn't needs very huge table, but use a little table, and mostly make mostly table, and now we have modern tables or periodic tables. Okay, how can to locate the elements in the periodic table? We have first representative element S and B block. We can describe our periodic table from this table. How can we know the periodic table and locate the elements in the periodic tables? By electronic configuration. If we can to make electronic configuration good, you can to locate these elements in the periodic table. We have 2 types in groups. We have A groups and B groups. A groups, modern periodic tables, we have 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 0. How can you locate these? By electronic configuration. If the farthest sublevel is S1, these sublevels, farthest sublevels in the last S1, 1A, and we can call number 1 in modern number. S2 is 2A, it is 2. This is number defines from the number of what? Of the principal. S2, B1, 3A, 3A, 13. 13, it is the modern number or the number of column. We have S2, B2, summation 2 plus 2 equal 4A or 14. This is the modern number of a column. We have S2, B3, 2 plus 3 equal to 5A. This is 15. For examples for this, we have S2 plus 4, 2 plus 4, this is a number power in S and P, 6A, 16. S2, B5, summation 2 plus 5 equals 7. This is 7A and 17 columns. Last one, S2B6, is a noble gas, not 8, but 0, because its valency is 0, and we can, on modern, is 18, and the column 18. The various number, if you have 3s, 4s, 5s, 6s, and so on, we can call 2s period 2, 3s period 3. We can, the last numbers here, this is the periodic, and the period number is defined from the number that precedes the farthest sublevel S or B. For example, if electronic configuration is 5s, so it is this electron, this elements found in period 5. We can that it is period 5 or fifth period. Okay, now we can determine the location of any elements by know the number of n or number of before S or B, farthest S or B, and the number of this express the number of period. Number n power S or B or summation S and B, it is the locations in this group 1A, 2A, and so on to 0. And we have the transition element location, it is the middle of the periodic table. We have ns2 n minus 1 d1, 2 plus 1 3b, not 3a, 3b, or number 3. ns2 n minus 1 d2, we can call n 4, this is 3, 5, this is 4, 6, this is 5, 7, this is n minus 7 minus 1, 6d. But the number of period, obey the number here, n, not n minus 1, 4, 3. So the number of period is n, not n minus 1. ns2, d3, 5, b. N here, ns2, d5, d1, sorry, 1 plus 5, 6b, or 6. This is number 3, 4, 5, 6, according to the 6b, 6. S2, d6, this is 8, 8, 8. This is numbers of electrons. These electrons here, this 7, 8, 8, 8, because these elements very similar in its properties, like iron, cobalt, and nickel. 8, 9, 10, this is the column of the periodic table. This is the number of columns in the periodic table. NS1, ND10, 1B, NS2, N minus 1, D10, this is the group 2B, or 12. Now this is the transition elements, and we have inner transition element. We can to know the number of period, because F is instituted in this between S and B. Periodic table of elements, we can describe these elements here. This is group 1A, 2A, or 1, column 1, column 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. This is the last group is 18. And we can call this is 1A, 2A, 3A, this is 3A, 4A, 5A, 6A, 7A, and 0. We have inert gases here in these regions, or noble gas. Transition elements in the middle of periodic table: 3B, 4B, 5B, 6B, 7B, 8, 8, 8, 1B, 2B. Or we can this column is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have inner transition element below this table. To keep the shape of this table, we put these elements below. We have 14 elements in each period. Period 6, lanthanides follow period 6. Actinides follow period 7. We can explain or illustrate this table. From this example, you can choose chromium for S1 3D5, so it's 6B. Here zinc is for S2 3D10 and 18, or 2B. We have copper for S1 3D10 and 1B or 11. Here manganese for S2 3D5, 7B or 7. Okay, you can to know the location of any elements in periodic table by detections or by using electronic configuration. By using electronic configuration, can we call the position of elements in this regions. Trends and periodicity of properties in the periodic table. We can discuss the properties of periodic table. We have explained the principle of arrangements of elements in the periodic table and have discussion the relations between the electron structure of the elements. We can write this. We have explained the principles of arrangements. What the meaning of arrangements? We have many properties like radius, electron negativity, ionization potential, electron affinity, oxidation number, and ionic property or covalent property. We can predict this properties by using electronic configuration and locate these elements in the periodic table, and you can to arrange it according to its property. I will discuss it another time. We have explained principles of arrangements these elements in the periodic table and have discussed the relations between the electron structures of the elements and its location in this table. We will know that about this explanation, the graduation of physical and chemical properties in the periods and their relations with these electron structures. We can to discuss this, and we will to concentrate our study here on the trends on the properties. These main groups elements only like S or B D block, S or B or D block. This study and this trends about these properties like a radius of this of these elements. What the meaning of atomic radius? We can discuss this circle. Okay, this is a circle. This circle, you can know the radius of this circle by the measurements, the distance between the middle and the center of this circle, and last of this place, you can to calculate this radius, and so on. A, B is the radius of this circle, or A, C is the radius of this circle again. Okay, and you can D is the radius of this circle, because A, B, AC, AD are equals because it is the same radius. What is the meaning of radius? I call the radius of the straight lines from the center to the circumference of the surface. This is the circumference of this series, and this what in this half. This is a half of distance. If you this is a diameter, you know mathematicals. This is geometry. In the geometry, we have a diameter from here B to D. This is a diameter. Half of this distance is straight lines. We can to call it radius. This radius of circle. It is half length of this diameter. Okay. can you write or can you define the radius of atom like that? This is any questions for all students. No, because atom is not circle. Can the concept of the radius for an atom be the same as the previous definition? Is not correct, because atom is not a circle, but atom is a sphere. Okay, what is the difference? We can discuss this. No, atomic radius not the same, because it is clear to us from its latest figures. This is figures we can show that we have electron cloud, not definite place, because we can to locate accurate place or accurate location of the electron around the nucleus. Schrödinger said that before, electrons can be found in this region at the same places in many directions or many dimensions in the sphere. Okay, how can you define the radius of atom by the same of circle? It's impossible to determine that. This is clear for these places and these places, this difference from the circle. How can you locate the last electrons to the atom? No, we can't locate this. Okay, so you can't determine or detection or calculate the radius by physical ways, but you can different ways to define or determine this distance. How can I make that? This is a distance here, not here, maybe here, maybe here. You can to detect the distance from any places? No, it is difficult. It is impossible, not is difficult, because a wave theory shows that the position of electrons around the nucleus cannot be determined exactly. Focus on these words. You can't be determined exactly. We depend on wave equation, the position of electron probability in any places around the nucleus. So it is would be wrong to define the atomic radius as the distance from the nucleus to the farthest electron, because we can't locate the farthest electron accurately. We have not accurate place, not accurate region, this probability to found in any places around the nucleus. Okay, now we will discuss the covalent and ionic distance or ionic radius. The concept of covalent radius is in this place. If you calculate the distance between two nucleus and two atoms, two nucleus in two atoms, and these two atoms identical: oxygen, oxygen, nitrogen, nitrogen, chlorine, chlorine, hydrogen, hydrogen. You must choose a molecule consists of two atoms, and these two atoms are identical, not different, because these diameters, we can determine this distance between these two nucleus equal 198 picometers. Okay, you can calculate the half distance. The half of distance is the radius. Half of this distance is the radius. So half of it. This is distance between the center of two similar atoms in the atomic molecule. Okay, now we can to calculate the radius of any diatomic molecule by using this idea. This is called covalent radius. Covalent bond length. If you calculate covalent bond length of two atoms in molecule in diatomic molecule, the distance between the nuclei of two bonded atoms is called the bond length and is measured in angstroms. Angstrom, it is a unit equal to 10 power negative 10 of meter. Bond length divided 2, it is equals to the atomic radius of each one. We have this example in this table: hydrogen, bond length equal to 0.6, so radius equal to 0.3. We find here fluorine equal to 1.28, radius equal to 0.64. Cl equal to 1.98, so equal to 0.99. Bromine 2.28, Cl Br equal to 1.14. Iodine equal to 2.660, so equal to 1.37. If you divided this number into number 2, so equal the radius of these atoms and these atoms. Okay, did you understand these tables? Because we can show these numbers you have. We find these bonds, and this exercise we can discuss to train of the bond length. The bond length in the chlorine molecule equal to chlorine molecule Cl2, Cl bond Cl. This is expressed as a bond is 1.98 angstrom, and bond length between carbon and chlorine CCl equal to 1.76 angstrom. Calculate the atomic radius of carbon. We know that. Okay. Cl plus Cl equal 1.98 angstrom. C plus Cl equal 1.76. If you know the radius of Cl, okay, you can subtract the radius of Cl from 1.76. Now, can you calculate by a mathematical equation to know the radius of carbon? The atom radius of Cl equal to bond length divided 2. In chlorine molecule 1.98 over 2 equal to 0.99A. The atomic radius of carbon equal bond length between carbon and chlorine. Atomic radius equal to 1.76 minus this number. Now we can the calculated of the atomic radius of chlorine equal to 0.778. We have another things about ionic radius. Can you calculate the atomic radius of ionic bond like the covalent bond? The answer is no. Why? Because the ionic bonds, the bonds is not found, because it have no characteristic to determine the distance. We have no distance to calculate it, or can you determine it? In the ionic crystals constructed of cations and anions, example sodium chloride, NaCl. We have NaCl crystals. The distance between the centers of cations and anions in the formula units can be measured by the technical methods. These technical methods now we can call the technique mentioned previously. The distance between the center of two atoms and the sum of their two radii, this is atomic radius, measured in this way, is known as the ionic radius, and depending on the number of electron loss or gain. Now, to know the bond length, you can to determine, or you can to summation the radius of Na positive plus radius of Na negative. I mean atomic radius? No, I mean ionic radius, not atomic radius, because it's not molecule. It is molecule formed from ionic bonds or ionic compounds. Exercise, we have some ions like Na positive, K positive, Mg positive 2, Cl negative 2, and Br negative 1, iodine negative 1, oxygen negative 2, sulfur negative 2, and this number is ionic radius of these cations. From the following table, calculate the bond length to potassium bromide. Potassium bromide. We have potassium here and bromide here. This is anion. Okay, you can to sum the number of Na positive with Br negative, so you can to or can obtain the distance or diameter or the bond length. NaI 1.02 plus 2.2 equal 3.04 angstrom. KBr 1.38 plus 1.98 equal to 3.34 angstrom. MgO 0.72 Mg or 0.72 plus 1.4 oxygen negative 1.84 or oxygen here 1.4 equal to 2.12. So it is the way to determine the bond length of any ionic compounds. We have effective nucleus charge. What the meaning of effective nucleus charge, and what are the effects of the electron nuclear charge? Firstly, what's the meaning of actual nuclear charge? Actual, not effective. If you have a difference about effective and actual, yes. Actual, the number of protons inside the nucleus. But the effective is different because it's not all the protons can to attract the electron valency in this atom. It means the number of protons inside the nucleus positive charge. Okay, what the meaning of effective? The effective nuclear charge is the net positive charge. Okay, net positive charge that affects only the outer electron in the multi-electrons atom. This charge is less than the total nuclear charge. You must know is not equal. Actual nuclear charge is less than already the effective nuclear charge. Effective nuclear charge less than an actual nuclear charge because it depends on the ability to attract the outer electrons in the outer energy levels. This charge is less than the total nuclear charge due to the tilting effects caused by the inert electrons, which reduces the position charge of the nucleus on the outer electrons. So we can know the factors affects to the effective nuclear charge. What is the factors? Number one, number of protons inside the nucleus. Number two, number of principal levels around the nucleus, and number of electrons inside this principal levels. By increasing these levels, effective of nuclear charge decrease. By increasing number of protons inside the nucleus, effective nuclear charge increase. We have directly proportional and inversely proportional between these factors. Effective nuclear charge. This effective nuclear charge is influenced by several case factors I told before. a number of protons in nucleus. By increasing number of protons, the effective nuclear charge increased. This is directly proportional. Okay, shielding affects inner electron repel outer electrons, reducing the effective nuclear charge felt by outer electrons. Effective nuclear charge, we have factor number 3, electrons in the same energy levels repels each other, slightly reducing the effective nuclear charge. The distance from the nucleus. Electrons farther from the nucleus experiences lower effective nuclear charge due to increased distance. Now we can discuss this diagram. This diagram this is a relations between effective nuclear charge and atomic radius. By increasing atomic radius, by increasing effective nuclear charge, the atomic radius decrease. We have inversely proportion between them. Okay, this is effective nuclear charge. This is atomic radius. We can show and we can learn the relations between them, between effective nuclear charge and atomic size. We want to know the graduation of the nucleus. Focus on the tables and these shapes we find here. Firstly, group 1A starts with hydrogen. Nuclear, we have atomic size is very small in this side. Atomic radius increase in this direction from top to below. Here, top to below, increasing. We find the increasing atomic size. This means the increasing of atomic size because increasing of diameter or atomic radius. If you discuss the graduation in this direction, in this period, from left to right, we find decreasing in atomic radius. So the atomic size decrease in this direction. Why? If you discuss the groups and periods, we can know this information. In the horizontal lines or the period, we see that the atomic radius decreases as we go from left to right across period. In the periodic table, we start from the first group and go to zero group. This is due to the increases of nucleus. Increases of the nucleus at charge gradually. Effective nuclear charge. Effective nuclear charge Z effect. This is a nuclear charge which is known by actual nuclear charge that affects the electrons in an atom. The effective nuclear charge always less than the nuclear charge, the actual nuclear charge. Number of protons as results of screening effects of the inner electrons or core electrons on part of this change of the electrons. We study that which increasing the attracts of the nucleus of the electron, attracts the nucleus of the electrons. So we find this attraction in the valency electrons leading the decreasing of atomic radius. This meaning that the biggest atom in size in a given period is that of first group and the smallest atom in the group 7 halogens. So 1A is the large group, 7A is the small group in atomic size or atomic radius. In the vertical group, We discuss from this shape by increasing atomic number, the atomic size increase from up to down. On descending vertical group, periodic table, the atomic radius increase. So, with the increases in the atomic number, this is attributed to 1. The effect of extra shells of electrons being added. The inner fields atoms orbits having the screening effects on the pull of the nuclear charge on the outer electrons, the increasing repulsive forces between electrons. We can to make this exercise in this way exercise the variations explain the variations in atomic and ionic radio for sodium, iron, and chlorine as shown in the following table. Okay, we can discuss this table. Radius A, and number of proton, and number of proton. Radius A 1.75 Na. Na positive 0.98. We can conclude the radius of positive less than the atom. We have 0.95. This radius less than 1.75, the radius of Na, it is atom. Fe 1.17, Fe plus 2, 0.75, Fe plus 3, 0.6. So this is decreasing. Okay. By losing of electrons, focus with me in these words. By losing of electrons, the nuclear effective charge increase. So the radius decrease. Because Fe plus 2 lose 2 electrons. So atomic size or atomic radius or ionic radius, ionic radius is 0.75. Here Fe plus 3 lose another 1 electron. So radius equal to 0.6. Cl 0.99. Cl negative 1.81. What's happening here? The nucleus of Cl negative is greater than its atom. Why? Because when chlorine gain 1 electron, the repulsion force increase. So we can conclude that ionic negative ion, its radius greater than its atom. But in the positive ion, its radius less than its atom. We have number of proton 11, 26, doesn't affect it. 26, 17. This number is stable, not changed, but changed. What is the change here? Number of electron 11, 10, 26, 24, 23, 17, 18. We can discuss this table to conclude what is the difference between the ionic radius, positive ionic radius, negative ionic radius, and its atoms. Now we have this solutions. In the case of metals like sodium and iron, it is observed that the radius of cation is smaller than the atom. This is due to increasing the ball of the effects nuclear charge on the remaining electrons in the cations. As the ionic charges increases as a form iron 2 to iron 3, the radius decreases. However, in the case of non-metals like chlorine, the anionic radius is larger than the atomic radius due to the increasing number of electrons, so the repulsion force between them increase without increasing the nuclear charge. Okay. We find, can you rearrange some elements or ions according to the atomic ionic radius? Of course, yes, because I can to make electronic configuration of these ions or atoms, we can to graduate it according to the periodic table, according to the rule I teach it now. Now I am students, now I learn about the graduation good, so I can to rearrange any atoms or ions according to its radius. Okay, follow next slides here. Next slides go. This is a periodic table. This is a periodic table. Now we have the greatest group in the periodic table. Which one? Greatest group of this radius is number 1A. Nice, very good. This is the greatest groups in atomic size or atomic radius. Okay, next, what is the smallest group in the size? Here it is the smallest group in size, 7A, halogens. Okay, next, which smallest period in the size? Smallest period. Okay, think a little, and now the answer is here. This is the period 2. This is the period 2 because it is the smallest in its size. Okay, next, which greatest period in size? Period. Okay, this is period 7. It is the greatest period in 7. Next questions, which greatest element? Okay, now we can to know in this by investigation. Okay, so the list here, cesium, because 1A, it is the greatest atomic, the greatest group in the periodic table and the atomic radius. Okay, so cesium, it is the greatest element in the periodic table. Okay, what is the smallest atom in size? So it is fluorine, F. Fluorine, F. It is the smallest one. Okay, now we can discuss these elements in the periodic table. Next question, arrange these elements in ascending order of their radius. Now we have many atoms. Okay. After node period is number of groups number. Now we make electronic configurations of some elements. Number 1, X35, Y17, Z11, A9, and D17, A53. Now making electronic configuration of each one. And we can to locate each one in the periodic table. Here is period 4, group 17, period 5, group 1, period 3, group 1, period 2, group 17, period 3, group 17, period 5, group 17. Now we can to make this. What this? This is arrangement of these elements in the periodic table. We have 2, 3, 4, 5, 6. We have group 1, 2, 3, 4, 5, 6, and so on to 13, 14, 15, 16. We can to arrange it by this way. We have A, B, C, X, Y, Z. Okay, this place of what? Of X. This place of Y. This place of Z. This is location of A. This is location of next, E. Next, this is the arrangement of these elements. Because we have in this side decreasing, in this side increasing of atomic size. Okay, so the arrangement ascending AD, X, E, Z, Y, Z, Y. Now we have this exercise, which bond is longer, iron 2 chloride or iron 3 chloride, and with the explanation that's okay, FeCl2 and FeCl3. What is the difference between them? Fe plus 2 and Fe plus 3 not equal, because Fe and Fe plus 2 lose 2 electrons only, but in Fe plus 3 lose 3 electrons only. So Fe plus 3 less than Fe plus 2 in ionic radius. But Cl negative 1 and the other is Cl negative 1 is the same. So the difference between these compounds, Fe plus 2 and Fe plus 3. So FeCl3 is less than FeCl2. The radius of Fe plus 3 less than Fe plus 2. Fe plus 2 more than FeCl3. Now this is the answer, and thank you for meeting. Now we discuss about the graduations of atomic radius, and next we discuss another things and its properties. وشكرا معكم، والسلام عليكم ورحمة الله وبركاته، مع تحياتي لكم وبالتوفيق والنجاح، ومع تحيات منصة البث المباشر.